So, we will be discussing significance of fiber properties for product development or for the product designing. We will try to understand what is the role of the properties of the fiber in relation to the development of a product, because this information is very important when it comes to the fact that we want to know what sort of fiber we are going to choose to develop a particular product. So, some understanding of the fiber properties and its possible influence on the property of the final product is important. So, let us now discuss this particular topic. So, now if we go to the next slide, this slide shows the fiber properties. We have classified them as dimensional or surface geometry of fibers. There are properties related to the mechanical aspect, that is mechanical properties. Then there are absorption related properties of a fiber. There are electrical properties of fibers, then thermal properties of fibers, chemical properties of fibers. So, the fiber properties can be classified into so many groups, and it is important for us to know what are these properties, how the properties differ for different types of fibers, and what could be their role. Now, what are the properties which are coming under, let us say, dimensional or surface related property of a fiber? These are basically length, fineness, density, cross sectional shape, crimp, surface roughness. These are all basically properties related to dimensions. As a length is a dimension, fineness is a dimensions, cross sectional shape is related to the also dimension, crimp in a fiber and roughness of the fiber surface. These are all related to dimensional or surface property of the fiber. Even the friction can also come here. This is another surface property which is could be also included, though it is not exactly dimensional, but is related to the surface phenomena. The other properties related to mechanical properties are related to strength, elongation, flexibility, toughness, resiliency. These are all mechanical properties of fiber. Absorption property basically means properties related to moisture regain or moisture content, absorption of water within the fiber, then retention of water by a fiber, dimensional changes if at all there, which is possible in some cases, that the fibers may show swelling, especially diameter swelling is important in many cases, and then there could be the weakening phenomena also could be a part of absorption. Then electrical properties are basically electrical resistivity and the static charge generation. Then thermal properties could be classified, and the properties relevant to the thermal are conductivity, softening and melting temperatures, combustibility, decomposition temperatures or behavior under sun rays. Then chemical properties are resistance to alkali, acid and oxidizing agents, organic solvent. These are all basically related to the chemical properties. So, a fiber which is the basic raw material has so many different types of properties, and we should be aware of the property of the fibers. Otherwise, we may ultimately select a fiber which may be wrong and may not be able to perform properly for a given product. Now, a brief idea. Most of you already know about fibers, but we will just give a brief idea of the fibers. Now, the fibers, we all know that there are two types of fibers, natural fibers and man-made fibers. Within natural, we can have animal fibers, plant related fibers and mineral fibers. They are all products of nature. So, fibers, the other group is man-made, and within this group we have regenerated fibers, and the other one is synthetic, which is organic and actually inorganic. So, we can write this organic and inorganic. These are the two types of fibers within the synthetic variety. So, you have a so many raw material available with you, and we have to decide which particular fiber we should choose for a given applications. The only thing we should know about this is that natural fibers, their properties are more or less fixed. We do not have much control on their property. Whatever nature produces, we have to accept it, because we really cannot engineer the properties in a natural fibers. Whereas, the man-made fibers, there is some scope for us to engineer the property. So, that is the advantage we have in the case of synthetic fibers, that properties can be engineered to some extent, whereas for natural fibers we have no control. Whatever the nature produces and whatever properties are there, we have to accept it, and we have to make a very clever choice in terms of choosing a fiber for a particular type of applications. Now, within the plant variety of fibers, we have also other choices. We have bust fibers, we all know that. We have leaf fibers, we have seed fibers, we have grass fibers, straw fibers. There are so many types which are there, and the advantage with the natural fibers is that it is a renewable resource. That is one of the biggest advantage with natural products. They are available and they are cheap generally. Fibers are biodegradable. Processability is generally easy. They are generally hygroscopic in nature. This can be beneficial in some aspect, some cases, and it can also be not so beneficial in some respect or in some cases. It has a short life, which could be advantageous or maybe disadvantageous also. It all depends on the type of product that you are going to design. Then other thing is stiffness, strength, recovery. Generally, they are not very strong and their elastic recovery properties are not so good in comparison to synthetic fibers, and some of them are also quite stiff. Not all of them, some of them, like wool is not stiff or cotton is not stiff or silk is not stiff, but we have some fibers which are very, very stiff, like all bust fibers like hemp or kenaf or flax. These are basically high modulus fibers within the variety of natural fibers. Then they are generally hygroscopic in nature, as we already stated. Then they are not odor free. They sometimes there is some odor with these fibers, they become being natural, and they are generally flammable. That is also one of the, you can say in some cases this is disadvantage, that these fibers are flammable. And in the man-made fibers, we have seen that inorganic and organic type of fibers are there, where inorganics are basically carbon, ceramic, glass, alumina, metals. These are inorganic fibers, and organic fibers are either regenerated, like wood from wood pulp, like acetate, cupra, lyocell, modal, triacetate, these fibers are regenerated fibers, and synthetic fibers are all polyamide, polyester, polyethylene, acrylic, monoacrylic, aramid, HMP. These are all synthetic fibers. And if we look at the general attributes of these fibers, all synthetic fibers, we can say generally say that because they are all produced under very controlled conditions, therefore, they are generally much more uniform in terms of their diameter uniformity and the uniformity in the property also. So, therefore, there are less variability there in the properties. Usually, they are quite strong. Most of them are generally quite strong in comparison to natural fibers, and they are very extendable also. Some of them are, not all of them, but many of them are very extendable, and properties can be engineered. That is the biggest advantage we have. And some of the fibers which we call high performance fibers, like high modulus polyethylene, which is Spectra is one of the commercial name of this fiber, aramid fibers, carbon fibers, silica, grass, silicon carbide, these are high performance fibers, and their attribute is that very high tensile strength and modulus, and being very high, very strong, they are suitable for those applications where stress level is going to be very high. So, for many composites applications, these fibers will be suitable. Then resistance to heat and flame, they are quite resistant to heat and flame also. Then resistance to chemical agents that normally degrade conventional fibers. So, these are very, in a very nutshell, these are the attributes of the man-made fibers in general. Normal man-made fibers are suitable for mostly your clothing type of products, whereas high performance fibers are suitable. They are not suitable for clothing at all, but they are suitable for other applications where, as I said, either the product has to face very high temperature, or there are a lot of force or a lot of stress which are going to act on it. In such situation, these fibers are going to be suitable. The other variety of fibers which we have is called specialty fibers. Now, these fibers have selected performance properties such as their dyeability, adhesion, absorbency, conductivity, flame retardancy, and response to external stimuli, or they have special surface characteristics. So, there is a group of fibers where we can engineer such properties and make them, let us say, much more absorbent. So, they can absorb much more liquid because of some modification that we carry out on these fibers, or we can have conductive polymers or fibers which can conduct electricity, or we can also modify fibers and make them flame retardant. So, these are basically a group of fibers which is known as specialty fibers. So, these properties are obtained by using additives such as colorants, flame retardants, conducting fillers, antistatic compound, etc. during the spinning process, or the surfaces are modified using chemical finishes for specific properties such as hydrophilicity, high absorbency, low friction, etc., or by some plasma treatment. The surface property of the fibers can be changed, or by special spinning process to produce different cross-sectional type, bicomponent fibers, microfibers, nanofibers. So, these are the three different methods, either by using additives, or by modifying the surface, or by some special spinning process, we can change many properties of the fiber, and these are known as specialty fibers. So, as a designer, we must be aware of the type of material which is available with us, so that we can give much better and better product. Now, we will discuss the various attributes of the fiber and their possible role or their significance. The first thing is, first parameter that we are going to discuss is fiber fineness or linear density of the fiber. Now, we see a table where the typical fineness values of some fibers are listed: cotton, linen, wool, silk, viscose, rayon, polyester, nylon, acrylic, polypropylene. Their corresponding diameters in micron also given. On the right hand side, we see a table where we have classified the fibers in terms of superfine fibers, finest fiber, fine fiber, medium fine fiber, coarse fiber and coarsest fiber. So, we have a very wide range of fineness with us, and we can choose the right fineness for a product that we intend to design. So, there is an enormous choice in terms of fineness that we have to keep in mind, and we will decide actually what fineness is required for a given product. The fineness for the natural fibers are generally limited, because whatever nature produces, that we have to accept, and we see that the fineness of cotton can range between 1 to 4 decitex, linen could be somewhere between 1 to 7 decitex, wool can be 2 to 50 decitex. Like that, different fibers at different range of fineness. For synthetic fibers or man-made fibers, the fineness can be varied, because here is something which is within our control. We can produce a particular fineness that we want. So, there is no problem there, especially for man-made fibers, but for synthetic or natural fibers, that sort of control is not there. The next thing comes that what is the role of fineness that we should try to understand. Now, here there are certain formula which will help a designer to make certain calculations if he wants, or if maybe sometimes required, like we want to know how many fibers are there in the cross section of a yarn. So, there is a formula which is given, very simple formula. From there we can find out how many fibers are there in the cross section of a yarn. Or we can also see the fiber diameter. There is also a formula given here, that is in micron value the formula is there, and fiber diameter the formulas are given in centimeters unit or in micrometer unit. And we can find out that if I change the fineness in terms of denier, what will be the change in diameter of the fiber. And then also, if it is required to know the specific surface area of the fiber, then that is also given by this formula, that is also stated here. So, all this formula is going to help us to find out certain parameters which may be needed while trying to design a particular product. Then quantitative relationship between fineness, one of the very important property which is affected by fineness is bending rigidity. So, bending rigidity is a function of quite a few parameters of the fiber, where bending rigidity B is shown here. It depends upon shape factor, tensile modulus, linear density of the filament or fiber and filament density. These are the parameters or the properties which affect bending rigidity. And therefore, if we look at here, we see the linear density, that is T, is coming in square term. That means, bending rigidity is going to increase disproportionately if we increase the linear density of the fiber. So, if we go from, let us say, a fiber denier 2 and we increase it by 2 times, let us say make it 4, bending rigidity is going to increase by 4 to the power square, that is 16 times. That is how the bending rigidity is going to increase. So, when it was 2, suppose bending rigidity was 2 square 4, but when it is 4, it is going to be 16 times. So, there is a huge increase in bending rigidity as you increase the linear density. So, a small change in linear density can make the fiber very flexible, and if the fiber is flexible, the yarn is going to be flexible and the fabric is going to be flexible, and the fiber clothing that we are going to make also going to be flexible. So, they are all connected directly to the flexibility of the fiber, that is bending rigidity of the fiber. Then the other important thing which is important in some cases, that is the capillary radius. We all know that in some situations the product is going to absorb some liquid, maybe is going to absorb sweat if it is a wearable material or product, or it can also absorb liquid for some other industrial applications when we have swab or we have some other product where you want to absorb some liquid. There what matters is the capillary radius. Capillary radius depends upon the diameter of the fiber. Considering the diameter to be fiber to be circular, the formula is capillary radius R is going to be 0.1135 into df, where df is the diameter of the fiber, and diameter of the fiber in turn is related to linear density of the fiber also. The other thing is capillary pressure. Capillary pressure P is stated here, and if you look at here in this equation, these are very standard equations which are available in many textbooks, and derivations are also there. We are not going into the detailed derivation of this. We are simply choosing the formula and trying to understand the relevance of fineness and the significance of fineness in terms of affecting these properties. So, capillary pressure, we see the value of R is coming in the denominator. That means that if R increases, the pressure is going to be less. So, capillary pressure will indicate how quickly the liquid is going to be absorbed by the capillaries which are formed within a bunch of fibers. Suppose it is a non-woven product. So, the capillary radius in non-woven is actually going to be much larger than what is stated here, because non-wovens have a lot of porosity, but in the case of yarns where we may have the value of R is this, which is stated here, capillary radius is this value. It is stated in the situation when the fibers are actually touching each other, like a situation which has been given here. When the circular fibers touch each other, that is, they are quite well packed. Then the capillary which is formed at the center as shown in this diagram on the right hand side, the radius of that is what is stated here. That means, it is almost a close packed structure. So, capillary radius, what is being shown here, the assumption is that fibers have formed a close packed structure, and in that situation this is the value of the capillary that we will get. However, in actual cases, if the fibers are not touching each other, the value of R is going to be much larger than what we expect as per this given equation. Anyway, the point is that the R is coming in the denominator, and therefore, if R increases, pressure is going to will be reduced, whereas if R reduces, then pressure is going to increase. R in turn is dependent on, always dependent on fiber diameter and also dependent on how closely the fibers are packed into the structure. But fiber diameter, that is fineness of the fiber itself, is also very important. Therefore, fineness can affect the capillary pressure, it can also affect the bending rigidity, and these will have its own effect on the product performance, depending upon where I am going to, what type of product I am going to make. Okay. The other important facts about this fineness is that, let us say the property wearing comfort, where stretchiness is important, lightness, slippability, prickliness, these are important property which will give you wearing comfort. There are some other property also could be there from the point of view of wearing comfort, but we are focusing on these 4 property here. And the microclimate control is also listed here. It is the warm feeling, reduction in sweaty humidity, stickiness, waterproofness. And if we see here the fiber linear density from fine to coarse, if we go, then what is going to happen? Stretchiness is going to be reduced, lightness is going to be lower if we use coarse fiber. Slippability is also going to be lower if we are going to use coarse fibers. Prickliness is going to be higher if we want to go for coarse fibers, that is prickle sensation is going to increase if the fiber diameter is large. So, some properties of the product or the fabric on the left hand side, and how the fineness of the fiber is going to affect it. In a qualitative terms, it is shown in this particular table. From there, if we go to the other property like easy care. Now, is the fiber linear density has some role here on easy care? If we look at this, then we find that from the point of view of crease resistance, see whenever the fabric or the product gets creased, then we need to decrease it, otherwise the creasing tendency or too much of crease that is gets formed on a clothing, then we actually discard it and we have to go for ironing it also in order to remove these creases. So, anti-crease treatments therefore are given in some product also, in some fabrics also. Now, point is what is the role of linear density here? Now, if the linear density is higher, in that case, that is if we go for coarser fibers, then crease resistance is going to be higher. So, this size is coarser, this is a continuation of the previous table. So, what we see here on the right hand side, that is if we go back, right hand side is coarse, extreme right hand side column, and the column just before that is fine. That means, here this is under coarse. So, if we go for coarse fiber, crease resistance is going to increase, is going to be higher. If we go for coarse fiber, wrinkle resistance also is going to increase. If we go for coarse fiber, abrasion resistance is also going to be higher. If I go for coarse fiber, peel resistance is going to reduce. The other important property could be tactile comfort. So, it is because of the sensation that we get when we touch a fabric or when we wear a fabric. Now, compressibility will be lower if the fiber is coarse. Why? Because coarse fiber means very high bending rigidity, and therefore, the fabric is going to be, we will feel it to be quite harsh and stiff, and hence softness is going to reduce as a result of, that is why the compressibility of the fabric is going to reduce. It will not be compressible easily, we have to apply more force to compress it. Friction property also will be affected by fineness of the fiber. If we go for this side is fine fibers, if we go for fine fibers, friction is going to be higher. When everything remains same, because with fine fibers the surface area of contact is going to be large, because the surface area of the fiber is a function of, a specific surface area is a function of fineness of the fiber. Hence, the friction is going to increase. So, I am not going to discuss each and every point, each and every property as stated here, but a general feeling that you get is that in some cases coarseness is what is required, but in some cases coarseness may be detrimental and we should go for fine fibers. It all depends what is the nature of the product that we are aiming for, what is the real positive attributes that we want to incorporate in the product. If I want to make a product very soft, let us say for a let us say clothing material for babies. Now, for the babies we have to produce something which is very soft. So, if I want to have a soft a product for the babies, then we have to choose a fiber which is very fine. We cannot choose a very coarse fiber for a product which is going to be used by babies. So, we have to think of incorporating softness in the product, and if we start thinking from the fiber, then first thing that will come to our mind is that we have to choose whatever fiber we choose, we have to choose a fine fiber. Then comes which fiber I should choose. We have to look for a fiber which is skin friendly, which is by fiber by itself is soft also, like viscose rayon fiber is generally very soft, or very fine cotton will be soft, but viscose rayon is very soft, and we may choose viscose rayon or polynosic fibers which are soft. So, and fine fibers we can think of mixing with some polyester, this and that we can do, but we have to think of fibers which are intrinsically soft, and then we have to play with the fineness of the fibers. We have to go for finer fibers which also make the product very soft, yarn soft, and then we can think of, we will come to that, the once we choose fiber, we choose the fineness of the fiber, then it comes, do I go for some twisting in the yarn or not? If twist is there, how much twist I should put? We will see that twist also has an effect also of softness. Then comes what type of fabric I should make. So, what is the role of fabric construction on softness? Should I go for a woven material or should I go for a knitted material, which will be soft? So, when a particular attribute of a product needs to be incorporated into it, then there are so many options that we have, and we have to keep it in mind that the option always starts with the raw material, and then for each and every stage of production there are certain parameters which may also have a role. So, that yarn may have a role, the fabric construction also have a role, the type of fabric also may have a role, then the finishing techniques also may have a role. So, at each and every stage there is a possibility of influencing the final property that we want to impart. Okay. Next thing which is important to us is fiber length. Now, what is the role of length in the product design? Mainly length is important from the point of view of processability of the fibers. That is, when it comes to process the fibers on certain machines, the length may have some influence there. Very short length fibers are difficult to process on certain technologies. That is the from processing point of view, therefore, it can affect. The other thing is the surface continuity. Longer the fibers, the surface continuity is going to increase. Instead of a suppose 1 inch fiber, if I go for 2 inch fiber, the surface continuity is going to be more, and if we go for filament, then it is continuous, there is no break. So, surface in that case completely continuous in that case. The length can also affect the strength and elongation in the case of non-woven. So, in the non-woven, there is no yarn which is used, and we do not put twist into the non-woven also. So, what will affect the strength and elongation of non-woven product? There the role of length of the fiber is very, very important. There are other factors which can also influence, but length will have a very important influence on the strength and elongation of the non-woven. Generally, long length enhances the tensile and tear strength and elongation of non-woven products. The other thing we can say that in spun yarns with long fibers, luster and softness is going to improve. Why softness is going to improve? Because with long fibers we will need less twist. So, the twist is less, the yarn packing is going to be less, and therefore, yarns will feel very soft. With less twist, yarns will be soft, and therefore, the fiber the fabric also will be soft. The luster is another thing which is also going to improve with long fibers, because the hairiness is going to be less as shown it here. So, these three properties are going to decline, hairiness is going to be less, fuzziness of the surface is going to be less, therefore, peeling tendency is going to be less. So, these are the advantages while trying to use long fibers. But a luster as a result of reduction in hairiness is going to improve, and softness is also going to improve, because mostly we will use less twist, or in the case of natural fibers, especially for cotton, long fibers are also very fine. In the case of synthetic, it may not be, because that is in our hand, we will decide what length we should cut, but for cotton, length and fineness go together. A long fiber is always fine, a shorter fibers are always coarse. So, the moment we say long fibers we are using for cotton, it automatically means that the yarn is going to be soft, because the fibers are soft. On the top of that, we use less twist, and therefore, we make the yarn further, we make them soft, because twist is also less. So, these are the importance of fiber length on some product quality. The other aspect is the surface roughness. You look at the SCM photographs of some fibers which are shown here, the different types of fibers which are here. Cotton is here, this one is cotton, this one is silk, this is wool, and this is polyester, and this is also the cashmere, this is alpaca. So, different types of fibers are shown here, and we see that the polyester surface is smooth like a rod, very, very smooth like a glass rod. Cotton, if you look at it, it is definitely not round. If we cut the cross section, we all know that it shows a kidney bean type of cross section, and the fiber is as if twisted itself. The fiber, single fibers are actually following some kind of helical configurations are there. So, surface, whereas the wool type of fiber have lot of scales, and the surface is very, very rough. Now, the surface property of the yarn fabric is therefore going to be affected, because the fiber itself surfaces of different fibers are different from each other. Now, surface roughness will affect which properties? Cohesion between fibers, luster of the yarn or fabric, smoothness of the fabric, thermal resistance value also will be affected, hand value and wicking. So many properties will be affected because of the roughness of the surface. Sometimes we want to make the surface rough, especially for some fiber like polyester, where the surface is very very smooth and therefore, it is too lustrous, and too lustrous fabrics are not really liked by many people, and hence we have to make the surface of the polyester fiber little rough. How do we do it? The simplest way is to add TiO2. If we add TiO2, the surface of the polyester fiber will be rough, and therefore, it will have a beneficial effect on the luster value of the fabric that we make out of these fibers. Besides, we all know that TiO2 also helps in terms of enhancing the life of a product which are exposed to sun. TiO2 is deliberately added in some fibers also in order to protect it from UV rays of sun. So, that way TiO2 also helps, is a UV protector. At the same time, it makes the surface a bit rough. So, if we want roughness, that we do not want a very slippery surface, or you want a surface which is not too lustrous, then we add TiO2, that is titanium dioxide. Then comes various types of cross sectional shape, is another interesting part of the fiber. So, we have fibers of so many different types of cross sectional shape. Here we see here serrated type of fibers, rayon, that is viscose rayon, kidney bean cotton, round, hollow, trilobal, hexagonal, octolobal, polygonal, 4DG, dog bone type of shape. So many types of shapes are there for different fibers, and the point is whether the cross-sectional shape really matters or not. It does matter, and therefore, we will see what are the property which can be affected because of cross-sectional shape. The cross-sectional shape of different fibers are listed on the table also, just to give you some idea. The properties which are affected are cohesion first of all, then bulkiness. See, sometimes we are looking for bulky products. Product has to be very bulky, so that the from the point of view of to enhance the insulation value, we want bulky product, or we want to make a product very soft, therefore, we want to make it bulky. So, bulkiness is also affected by the cross section. The other thing which is affected is luster also. Then covering power, because if bulk is affected, covering power will be affected. If the bulk of the yarn is affected, then covering power of the fabric by the yarn also will be affected. Then comes softness, thermal resistance, hand, wicking. So many things are affected by the cross sectional shape of the fiber. There are some fibers which have very high wicking rate, like 4DG fiber, this fiber very high wicking, octolobal polyester fiber, very high wicking rate. They have been designed to enhance the wicking property of the fibers, yarns, or the fabric. So, the cross sectional shape has been changed. What we have done in these cases, we have produced micro channels on the surface of the fibers, so that through these micro channels the liquid can pass very fast. So, that is one of the very one of the reason why we have gone for certain type of shapes. So, natural fibers also have different types of shapes which are controlled by the nature, we have no role there, but for the synthetic fibers many a times the shapes can be different types of shapes can be made or engineered depending upon the need of us. So, the properties which are affected by the cross-sectional shape, there are many properties which have been listed there. Now, if we look at the lustre part specifically, lustre depends upon the reflection of light as shown it here. So, we have seen 3 different cross sections and the way the light rays after falling on it, how it is reflecting back. If the reflecting while the light falls and if it gets scattered, then the lustre value will go down. So, the fiber either you see look at this fiber irregular shape, scattering will be more, round shape scattering is also still more, comparison to irregular shape it is less, but if we go for shape like trilobal, then scattering is going to be much less. That means, if we go towards flat surface, scattering is going to be less. So, more light will reflect back and fall on our eyes and the product will look very, very lustrous. Then packing, non-circular fibers form spiral edge similar to screw and thereby restricts the potential interfiber contact and high packing density. So, whenever the fibers are non-circular in nature, if we hold them together, we will find that the packing is much less, whereas if the fibers are circular in nature and if we hold them together and apply pressure, we will find that these fibers, the overall packing of fibers is much more. So, round fibers will encourage packing, we allow the fibers to come closer to each other, whereas all non-circular fibers will discourage packing. So, they will create more voids between the fibers. So, sometimes it is advantageous, sometimes it is disadvantageous also. When we want a very lean yarn to be produced, we have to go for round shape fibers. If we want a yarn where yarn where the porosity has to be high due to some other reason, then you have to go for non-circular fibers. The question, circular fibers increase surface area of contact in comparison to other cross-sectional shapes, and therefore, the question is also going to be more when the fibers are circular in nature. But if they are non-circular shapes, the question is going to be less, because the contact area between the neighboring fibers is going to be less. So, each and every effect can be explained, and but we should know that how the various properties are affected. Like here also there is a table which is showing how the cross-sectional shape affects optical properties, and the cross-sectional shapes and fiber surface are both shown here in a table, and qualitatively we are saying that what happens to the brightness, transparency, covering power, dye stuff consumption, dye depth or dirt visibility. The dirt visibility is important for carpets. There dirt visibility is very important. So, particle adhesion depending upon the type of product and specific attributes that we need in that product, we should choose the right type of fiber. So, that is why we should be aware of, like brightness is weaker with round shape fibers, stronger with triangular fibers as an example. Similarly, say covering power will be higher with hollow fibers or with triangular fibers. Hollow fiber means because of hollowness, the overall diameter of the fiber is going to be more. Each fiber will be larger when the denier is same, because there is a hollowness at the center. So, anyway, these different properties are listed here, property side and their effect are shown in this table. So, such kind of table if we make, even if we do not have the exact values here, this will help us to choose the right type of shape or the surface characteristics of the fiber. Similarly, tactile properties also are shown here, then bending resistance, polymerism. So, these are the related to tactile properties, how it is affected by cross sectional shape and fiber surface is all stated here. Similarly, your physiological property, moisture transport, insulation property are all stated here. So, insulation property depends upon, let us say, is very high with hollow fibers. Why it is high with hollow fibers? Because the hollow fiber will have, because the void space will contain lot of air, and therefore, the hollow fibers will give you very high insulation, because the hollowness is not only there between fibers, within each and every fiber there is a hollow part. This hollow part is going to contain air. All profile fiber will give you higher insulation, because fibers will not be able to pack very well, and therefore, there will be lot of voids between the fibers, and hence lot of air will be trapped, and therefore, insulation will be more. Okay. So, these are the different the properties and how they are affected is given here. Let us now move to the next one called crimp. Has the crimp has any role? The idea is, yes, crimp also has a certain role to play. See, some fibers are already having crimp, like wool fibers, are very crimpy, and the interesting part about wool is that it has 3D crimp. This is a fiber which has 3D crimp, and cotton fiber also are crimpy. So, crimpiness is important because it facilitates entanglement between the fibers. So, while processing the fibers on certain machines, the crimp is something which is desirable. Without that, we will not be able to have any cohesion between the fibers, and the fibers will all fall from the machine, and therefore, crimpiness is important. Where crimp is not there, these fibers are difficult to process. So, man-made fibers we introduce crimp by some means, so that they can be processed easily on different machines, especially on carding machines. Now, crimp will affect warmth and soft handle. Warmth is coming because of crimp, fibers will not be able to pack easily, and therefore, lot of voids will be there. And if it is there, bulk, loft, everything will be there, because the fibers are not going to come very close to each other. The crimpiness of the fiber will keep the fibers away from each other. It will also improve extensibility, it will improve the fiber, the whole bunch of fibers or the bulk is going to be very compressible. So, compressibility and recovery property is going to be better if we have crimp in the fibers. Like in carpets, we know that there is an importance of compressibility and recovery there. Elasticity and resilience is going to be better also if the fibers have crimp, and better wrinkle resistance, less flexural rigidity, better drape, good thermal insulations, everything can come from crimp. So, we have to remember that crimp has an important role to play in enhancing certain property in the final product also. Then fiber tensile property. Tensile property, typically all fibers that we use for conventional fibers, the tenacity value range is given here in terms of centinewton per denier or centinewton per tex. Tenacity of conventional fibers, high tenacity fibers, it is going to be 10 centinewton per denier. So, that is a typical tenacity. Most conventional fibers except cotton, jute and flax have very high breaking elongations. But cotton elongation is 7 to 8%, jute is much less, maybe 2%, 2 to 3%, and flax is also 2 or close to 2. So, these fibers have less elongation or less extension, but other fibers, natural fibers, have very high extensions, generally more than 15%. And modulus is also very important, and fibers can be classified as high modulus fiber, medium modulus or low modulus fiber depending upon these modulus. And for different modulus, the tenacity values, typical values are quoted here. High modulus fiber will have a tenacity 40 to 60, medium modulus fiber will have a tenacity range 20 to 40, and low modulus fiber will have a tenacity range 10 to 20 centinewton per tex. That means, modulus and tenacity are related. Higher the modulus, higher is going with your tenacity. Typical stress strain diagram of some fibers are given here. This is also available in many textbooks. Now, the quantitative relationship between strength and fabric is strong fiber leads to strong tear resistant fabric. These are very simple, straightforwardly they are connected. If I want a strong fabric, I have to choose for a strong fiber. Better shape retention when the fibers are strong, because they will not extend easily. Better key resistance also will be there, but too strong a fiber makes it very stiff and shows very low bending strength. So, if we bend, then they may break easily. So, bending strength is less when the fiber is very strong, because it becomes too stiff and it can easily break, especially when it is subjected to bending deformation. Glass fibers cannot be knotted, as an example. Glass fiber is very strong, but if we want to put a knot, it cannot be knotted. Tensile strength is very high, but it is going to decline on twisting. But all fibers which are extremely high modulus is there, their strength declines very fast on twisting, because their shear strength is low and twisting results in bending of the fibers, because the fibers will follow a helical path and therefore, the fibers will be twisted on their own axis and fibers will have to bend also, and all high modulus fibers becomes very weak if we try to twist them. So, generally all high modulus fibers are, when they are used in a given application, they are never twisted, or if at all we twist is there, twist is very low. This diagram gives you an idea, that is what was the modulus and tenacity of the fibers. Now, the textile fibers, general textile fibers for apparel use, they have a modulus, how much? The tenacity values were in this range, close to 5 plus minus 1 or 2, and their modulus gram per denier used to be 10 to 30. For textile it is from here to there, here. Textile basically means here fibers which are used for apparels mostly. Its tenacity 5 plus minus 1 or 2, and modulus used to be between 10 to 30. After that people developed fibers which are industrial fiber, like for carpets, for tire cords, for hose, and their tenacity level increased was between, let us say, 7 to 10, this range, and modulus range was between 30 to 100. And then came the high performance fibers used for tires, composite, aerospace, ballistic. There if you look at their tenacity range is from 20 to beyond 40 gram per denier, and their modulus comes in this range. So, high performance fibers have very high modulus and very high tenacity, whereas textile fibers for apparel use have a very low modulus and low tenacity. So, you see that with the increase in modulus, the tenacity is also going to increase. Other relevant property of the fibers which will be important are knot strength of the fiber, loop strength, elasticity, that is on tensile and bending, that is how much is the recovery property. If I subject a fiber to tensile deformations, how much does it recover, or if I subject it to bending deformations, how much is the recovery. These are important. Similarly, fatigue resistance is another property, is also important. It could be tensile fatigue, bending fatigue, and torsional fatigue. So, depending upon the end use, like fatigue resistance is important in the case of, let us say, tire cord. In a car tire, the tire cord which is there is repeatedly subjected to tension, and tension is going high, is becoming low also, depending upon the contact point of the tire with the road. Continuously it is subjected to tensile fatigue. It is important there. In some cases, let us say, a hauling rope is also subjected to tensile fatigue. So, there are textile products where fatigue resistance also could be very, very important. The another important property which I have not mentioned here could be abrasion resistance also. That also could be another relevant property related to also could be important. Some cases loop strength could be important, especially for sewing threads, loop strength is important. So, there are so many properties which are for the fiber is also important, and we must have create a data bank of the property of the fibers and keep it ready to be used by a designer. Somehow this kind of data bank is not there, where the such kind of property details are there for all types of fibers. Now, let us come to influence of fiber density. The table is shown here, density values of different fibers. Density, if we see here, it varies between 0.9 to 1.52 or 1.54, that is the typical range in which density of the fibers are lying. The fiber which has least density is either olefin fibers or polypropylene fiber is one of them, minimum density, or polyethylene fibers also have minimum density. Density is less than 1, that means they can float. in water, they are not going to sink. So, in some cases if we want a product which has to float on water, then this is the fiber for that, provided it satisfies other requirement also. And some fibers also may be having very high density, like say glass fiber has a very high density 2.49 to 2.73, but generally most of the textile fibers will have density ranging from 0.9 to 1.52. The lower density fiber makes the fabric bulkier and lighter, and they will give you better cover also. So, we have to reduce, let us say, the weight of a fabric. Let us say we want to design a uniform for the soldiers, where weight will matter. So, how to reduce the weight of the uniform of a soldier? We have to, there we can start thinking from the type of fiber we are going to choose, and therefore, density is going to matter here. Acrylic is used for bulky knitwear and blanket, as more air remains trapped within the structure. That is one thing, and acrylic is also very light as well. So, the pullover which is bulky in nature looks, but it is very light at the same time, because I am using a fiber which is very low density fiber. But for very lean and heavy fabric, cotton, linen can be used.